Now in this problem we try to use Simpson's 1/3 rule to find the integral e power minus x square by dividing it into 6 subintervals. First let us see what is the interval in the given problem. In the given interval is 0 to 0.6. So the a value is going to be 0 and the b value is going to be 0.6. The next number of subintervals in the question they mention it as the 6 subintervals, so it's going to be n value is a 6. Now the function f of x or y in this problem is given as e power minus x square. So let me write the function y, which is e power minus x square. Now the next step is we have to decide the step size h, which usually calculated by using the length of the interval b minus a and the number of subintervals required. So the length of subintervals is difference of ab values, that is b minus a, which is 0.6 minus 0 divided by 6. When you simplify, it comes as 0.1. Now to get the successive values of x starting from the lower limit 0 up to the upper limit 0.6, we have to continuously add this step size 0.1 so that we will get the points x. And those points x we have to substitute into the given function e power minus x square to get the values of a corresponding one. Let us see feed these values into the table. See, the first lower limit, which we take it as a lower limit a, in this problem it is 0, and the upper limit, the last point, I think it is 0.6. this is the b value 0.6. Now as we know in this problem step size is h, we have to continuously add the step size h to get this remaining points. 0 plus step size h 0.1, 0 plus 0.1 is 0.1. Next once again add the step size h, that is 0.1 to this point. You'll get the next point as 0.2, adding h will give you 0.3, adding h will give you 0.4, adding h will give you 0.5, and the last value will get it by adding 0.5, 0.1, which is 0.6. Now these are the x values. In this case we have a function which is e power minus x square in the problem. Now feed these values into function, make use of scientific calculator to evaluate this function e power minus x square. It is e power minus 0 square, which usually 1 by e power 0, which comes as 1 by 1, which comes as 1. In the same way you substitute e power minus 0.1 whole square and evaluate the value, e power minus 0.2 whole square and evaluate the value. The same way all these values has to be evaluated. Let me write this. Now using scientific calculator, if you calculate the values, the 0.1 value is going to be 0.99. This is 0.99. The next value is 0.9608. The next, if you use scientific calculator and evaluate these values, so next one is 0.9139, 0.9139. The next 0.8521, 8521, and 0.7788, and next value 0.6977. These are the required values of y. Let me indicate this is y0, this value is y1, and y2, y3, y4, y5, and y6. Now how you're going to make use of these y values in numerical scheme, particularly in Simpson's 1/3, to evaluate this integral numerically. So For Simpson's one-third rule, it's very simple to remember this formula. This formula we can use it for writing the general expression for any number of ordinates. Doesn't matter whether it is a 6 intervals or 12 subintervals or 9 subintervals. Try to remember this basic form. From this you can generate the formula for any number of subintervals. So here the first and last means first y value and the last y value in a particular problem. First y value, this is 1, and the last y value is 0.6977, that is y0 and y6 is taken in this case. So let me write the formula for this particular case. H by 3 y0 plus y6 plus 2 times of even numbers. Even numbers in the sense, not even numbers, even y subscripts, that is y2, y4, y6 and etc. y6 is the last number, is already included, so only y2, y4 to be considered. So the formula will be y2 plus y4 and 4 times of all remaining values, y0, y6, y2, y4. So the remaining values are going to be y1, y3 and y5. Substitute all these values. H is 0.1 and y0, y6, y0 is 1 and y6 is, I think, 0.6977. Let me substitute 6977. In the same way, substitute the remaining values also. Y2 plus y4, which is 0.99, 0.9608 plus 0.8521. 0.9608 plus 0.8521 plus 4 times of y1, y3, y5, 0.99 plus 0.9139 plus 0.7788. While evaluating these terms, try to evaluate component wise, because at a time if you use as per the BODMAS rule you may get wrong answer. First evaluate the component wise, then multiply with 2, 4 and finally multiply with a 0.1 and the final answer divide it with a 3. So the approximate value you will get it as 0.5351. So this is the way how we have to use the Simpson's one-third rule.